Problem number 5. Again, let's go ahead and list our magic number, LCD. And we do that after we factor every denominator. And 2 factors out of these 2 terms here, and then m squared minus 4. That's the difference of 2 squares. So we have an m plus 2 times an m minus 2, and we have this m minus 2 over here. So what's the smallest number of factors that we can use? Well, we need a 2 in there. We have an m minus 2, and we also have an m plus 2. So basically we list all the prime factors. And we've got it. So that's our magic number. And then let's identify the extraneous solutions, possible extraneous solutions here. So m equals 2 would make that denominator equal to 0, as well as negative 2 would make these 2 denominators equal to 0. So if we get a 2 or a negative 2, we need to cancel those out, and hopefully we'll find other numbers. If by chance the only numbers we get solving this equation would be 2 or negative 2, after we do all of our work, then we would say there's no solution. So if we can't find any real numbers besides these, then there are no real numbers that would solve this equation. All right, let's see if we can do this a little bit shorter than we've done in the past. We're going to take, in the last 2 examples, we're going to rewrite this, and I'm going out on a limb here just to see if you guys can handle this, see how you like it. Let me know. I'm not probably going to remember to ask you, but please let me know if this was too much at once or if that was okay. So we're going to take our 2 times our m minus 2 times our m plus 2, and we're going to multiply it by all 3 terms. All right, so it's going to be a little mental math here. When we do that, when we multiply this magic number, the lowest common denominator, by this first fraction, we could see the m minus 2 is going to cancel. If the m minus 2 cancels with that m minus 2, what we're left with is the 2, the m plus 2, being multiplied by what's left, the 2m minus 1. So you can see you only get to cancel the m minus 2, everything left over gets multiplied by that numerator. Now, in this fraction here, the 2 and the m plus 2 cancel, 2 and the m plus 2 cancel, and you're left with the m minus 2. This is how I'd actually do the problem, showing that next step of showing this term, the magic number multiplied by every single one. That gets a little tedious to write, but if you like that, feel free, go ahead and do that if it helps you. Okay, now we're on to this last fraction here where the m plus 2 is going to cancel with that m plus 2. The m minus 2 is going to cancel with that one, and what's left over is this 2 here being multiplied by that 2, which means 2 times 2 is 4, and that's all we have. Now, we have a little simplifying to do. Let's go ahead and FOIL these out. M times m is 2m squared. M times negative 1 is negative m. And then we have 2 times 2m, that's 4m. 2 times negative 1 is negative 2. On the right side, we can see we can combine the negative 2 and the positive 4 to give us m plus 2. Well, before we distribute, let's simplify inside the set of parentheses. We can combine the negative m and the 4m, and that gives us 3m. And then we have that minus 2 still in there, and then we can't simplify the right side anymore. Now we're going to distribute this 2 to all 3 terms. 2 times 2m squared is 4m squared. 2 times 3m is 6m. And 2 times negative 2 is negative 4, equals m plus 2. Now this problem is a long problem. So now we want to subtract m. We want to gather all the terms to one side, and we're going to subtract 2 from both sides. Subtract m and subtract 2 from both sides. So we get 4m squared collecting like terms. 6m minus 1m is plus 5m. And then we have negative 4 minus 2 is minus 6 equals 0. So this should alert you to the fact that we've got a quadratic equation. And when we have a quadratic equation, hopefully the terms will, this polynomial on the left side will factor. Now, if it factors, most likely, it's going to have to be a 4m and an m. and then a 6 and a 1, or a 3 and a 2. Okay, so that would work. So we have a plus 2 and a minus 3, and that works. So I had to pause here. We got end of zero period just happened. Anyway, now let's move on up here and set each of these factors equal to 0. 4m minus 3 equals 0, and m plus 2 equals 0. 4m minus 3 equals 0. If you add 3 to both sides, we get 4m equals 3. And then when you divide both sides by 4, you get m equals 3/4. When you look back at the extraneous solutions that we've already identified, 3/4 is not one of those numbers, so we're good. So that checks out. Over here, however, if we subtract 2 from both sides, we get m equals -2. And when we look back, we see we have -2 listed as an extraneous solution, which is exactly what that is. And so we would say that is extraneous, and that's how we would list that. That's an extraneous solution. It's a solution we got because we did everything right, but it just so happens that -2 would be unacceptable to plug back into the original equation, because again, it would make both of these denominators equal to 0. And so the bottom line, m equals 3/4 is the only solution to this equation.